All right, so in 6.1, we talked about law of sines. 6.2, we're going to talk about law of cosines. So we use law of sines when we have a pair, like if we have angle A and side A, we can set up a proportion to find the rest of it. We have to use law of cosines if you don't have a pair. So if you're not given angle A and side A, or angle B and side B, when you don't have a pair, you got to use law of cosines. So we have two different formulas technically for law of cosines. We have standard form and alternative form. Standard form, we're looking for, what's the lowercase letter, a side or an angle? Side. So we use standard form when we're solving for a side. We use alternative form, what's a capital letter? When we're solving for an angle. These formulas will be given to you. All three of the standard form equations are the same. It just depends on which letter you're looking for. So if you're looking for A, you'd use the first one. If you're looking for B, you'd use the second one. So it was nice to write it all out for you. So let's look at example 1. We want to find the three angles of a triangle that's shown in the figure. It gives us the three sides. So we don't have a side A and angle A where we can set up a proportion with our pairs. So because we're just given three sides, we have to use our law of cosines. Now there's two rules that we have to follow when it's an SSS, when you're given a side, side, side triangle. So side, side, side. The first thing that we want to find is the largest angle. So we're going to work with the longest side first. So we want to find the largest angle first. What would our largest angle be? B. Awesome, because that's opposite of the largest side. So we're going to find angle B first. So our formula that we're going to use, it actually wrote it down here for us, is this one. So cosine of B is equal to a squared, so that's 8 squared, plus c squared, 14 squared, minus 19 squared, over 2 times a times c, so 2 times 8 times 14. Now just be careful when you're putting this into the calculator. Make sure you know how to use your calculator. I would always recommend just doing the numerator, putting equals so you get a number for that, and then you can divide it by the denominator. But since we have math going on in our denominator, you can put that in parentheses too. Or do them separately, get two numbers, and just divide them separate. So make sure you know how to use your calculator. So we get cosine of B is equal to negative 0.4508. It keeps going. Remember, this isn't our final answer. How do we find what angle B is? We do the inverse cosine, so that cosine -1 button, second cosine in our calculator. So inverse cosine, it'll cancel out with the cosine here, so we're just left with angle B is equal to, so in my calculator I do second cosine, second answer, to copy and paste my answer. We get 116.8. 116.8 what? What are we talking about here? Degrees. 116.8 degrees. Awesome. Now, the second thing that we need to find is going to be the smallest angle. So step 2 is we want to find the smallest angle next. So what would our smallest angle be? A is going to be our smallest angle. Now, since we have a pair, we have side B and angle B, we're going to use law of sines now. So we're going to do the same thing we did yesterday with our law of sines. We're going to do that with our pair. So I have 19 over sine of 116.8 is equal to 8 over sine of A. How would we solve this? What should we do first? Cross multiply, perfect. So same thing we were doing yesterday. We have 19 times sine of A is equal to 8 times sine of 116.8. And then we can divide both sides by 19. So sine of A is equal to, now we're going to put this in our calculator. So we have 8 times sine of 116.8 divided by 19. So we get 0.3758. It keeps going. But this isn't what A is equal to, it's what sine of A is equal to. So how do I find what just A is? Inverse sine. So we're going to do the inverse sine. So that's sine -1 button in our calculator. So second sine, second answer. To copy and paste my answer, we get 22.07, or I'll call it 22.1. 22.1 degrees. So that's our angle A. What do you think we could do to find angle C? Awesome. Once we have two angles, we can add them up and subtract from 180. So we can do 180 minus 116.8 minus 22.1. So for angle C, we get 41.1 degrees. So to find angle C, we did 180 minus 116.8 minus 22.1. So those are our three answers. We were given the three sides. We had to find the three angles. We have angle B, angle A, and angle C. So it's super, super important. When you have a side, you have to follow these steps. You have to find your largest angle first, and then your smallest angle. So we use law of cosines to find our largest one. Then we go back to what we did in 6.1 yesterday, and we find the smallest angle using law of sines. So with example 2, we have two sides in the included angle. We have side, angle, side. So looking at the triangle here, we don't have a pair that's given. We have side B, angle A, and side C. So we don't have angle A and side A. So we can't use law of sines right off the bat because we don't have a pair. But when you have a side, angle, side, the first thing we want to find is the side that's opposite the angle. So because we're given angle A, we have to find side A first. So when it's a side, angle, side, first thing we want to find is the opposite side. By opposite side, I mean the side opposite of the one angle that we're given. So since we want to find the opposite side first, we're looking for the side, we're going to use standard form. Standard form is when we want to solve for a side. So I'm going to use the first equation here, the first formula, because we're looking for A. So we have A squared is equal to B squared, which is 9 squared, plus C squared, which is 12 squared, minus 2 times B, which is 9, times C, which is 12, times cosine of A, which is 25. So let's put this all into our calculator. Just be careful how you put it into the calculator. If you want to put all of this into parentheses, you can. So there's a lot of math going on there. Make sure you know how to use your calculator. So we get A squared equals 29.237. It keeps going. Is this my A? Is this my side? No, what do we have to do next? We got to get rid of the squared. How do we do that? Square root both sides. So we're going to take the square root of our answer. So we get 5.4. 5.4 what? What are we talking about here? Meters. Perfect. This is side length, so we're talking about meters. So 5.4 meters. All right, so in side angle side, bless you, when we have a side angle side that we're starting with, first thing you have to find is the opposite side. Second thing we have to find is the smallest angle. So in side, first thing we had to find was the largest angle. Second thing was the smallest angle. Side angle side. First thing you want to find is the opposite side. Second thing is the smallest angle. So smallest angle is always second. So think second, smallest. Second thing you always want to find is the smallest angle. So which one out of C and B is smaller? B. So let's find B next. Obviously our smallest angle is angle A, because that's our shortest side, is side A. But just out of the two remaining, you want to find whichever one's smaller. So let's find B. And now that we have a pair, we can use our law of sines. So I'm going to set up my proportion with the A's. So I have 5.4 over sine of 25 is equal to 9 over sine of B. So we're going to cross multiply. 5.4 times sine of B is equal to 9 times sine of 25. And then divide both sides by 5.4. Then we're going to put this into our calculator. So we have 9 times sine of 25 divided by 5.4. 0.7043. It keeps going. What do we do to find what our actual angle B is? We do the inverse sign, so sine to the power of -1. So it'll cancel out there. So we get angle B is equal to second sine, second answer, 44.77. So I'll round it to 44.8. What are we talking about here? Degrees, awesome. So 44.8 degrees. How do we find angle C, our last angle? If we have two angles, what can we do to find the third? Awesome, add them up and subtract from 180. So we're going to do 180 minus 25 minus 44.8. And we get 110.2. So 110.2 degrees. So these are our three answers. Pitcher's mound on a softball field is 43 feet from home plate. The distance between the bases is 60 feet as shown in figure 6.9. The pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? So it draws the picture here for us. It gives us a side, the angle in between, and another side. We don't have a pair of side A and angle A, or here it gives us different letters, but we don't have a pair. So we have to use our law of cosines. So what do we have to find first? Awesome. We want to find, the first thing is the opposite side. Opposite side meaning the opposite side of our given angle. So we got to find H first. So we're going to use our formula. H squared is equal to 43 squared plus 60 squared, 2 times 43 times 60 times cosine of 45. So we're going to put this into our calculator. So you should get 1,800.329. It keeps going, but we're not done yet, so we're going to leave our answer in our calculator. What do we do to find just h? Square root both sides. Perfect. So h is equal to, we're going to take the square root of this. So we get 42.4. 42.4 what? Feet. That's all that this question's asking us for. It's how far is the pitcher's mound from first base. So it's just asking us for the distance here, which is h. If it was asking us to solve the whole triangle, what would we do next? What's the second thing we would want to find? The smaller angle. We'll say smallest angle. Smallest of what's left. So which one would be smaller? F. Perfect. So next we'd want to find F. So you can set up your law of sines now that you have a pair to find angle F. Next, we're going to talk about another area formula. So yesterday we ended the notes with an area formula when we had a side angle side. Here we have a different area formula when we're given a side. So when you're given the three sides of a triangle, you want to use Heron's area formula. So again, this formula will be given, same with all the formulas for law of cosines, and same with the other area formula. You just have to know when to use which formula. So Heron's area formula is kind of a two-parter. So we want to, first thing we have to do is find S. So S is the sum of all the sides divided by 2. So we have to find the special value S in order to use it in our area formula. So we add the sides a plus b plus c divided by 2. That gives us S. And then we're going to plug that into our actual area formula, which is the square root of S times S minus A times S minus B times S minus C. So let's do example 5. We want to find the area of the triangle below. So here it's a side triangle. We're given the three sides. So the first thing we want to do is find S. So S is A plus B plus C divided by 2. So 43 plus 53 plus 72 divided by 2. Let's put that in our calculator. So for S, you should get 84. Second thing we're going to do is actually plug it into our area formula. So our area is the square root of S times S minus A times S minus B times S minus C. So our S we said was 84 times 84 minus our A is 43 times 84 minus B, which is 53, times 84 minus 72. Yeah, you can put this all in the calculator at once if you want to. Just be careful with your parentheses. You can do it step by step if you want to that way too. So I'm going to say 84. I'm actually just going to subtract each one of the parentheses. So 84 minus 43 would be 41. 84 minus 53 is 31. And 84 minus 72 is 12. So I have 84 times 41 times 31 times 12. Same thing. You could put it all in the calculator from the start. Up to you. Depends on how you want to do it. So 84 times 41 times 31 times 12. We get the square root of a really big number, 1,281,168. Next thing we need to do is take the square root of that. So our area is 1,131.88, so I'll just call it 0.9. What unit are we talking about here? Meters squared. Perfect. Since it's area, your unit has to be squared. Last page just has the formulas for the area of a triangle. So it depends on what you're given. Obviously, if you're given the base and the height of a triangle, our favorite thing is 1/2 base times height. We know that from geometry. But in pre-calc, we're not going to be given just the base and the height. You're going to be given sides. If you're given a side, angle, side, you use the first ones that we did yesterday. If you're given side, 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 you want to use Heron's formula.